So, hello everyone. Now we are going to understand the concept of parametric and non-parametric test. You know, for our data analysis in research, we must know that the data, the sample which is drawn from our population, whether it is how it is drawn, if it is drawn normally or if they are distributed normally, it means we are going to perform parametric test. And if they are not drawn normally, or there are other assumption also, if they are not fulfilling those assumption, it means we are going to perform the non-parametric test. There are the various type of tests which we are going to see. Like for example, I will tell you, like independent sample t-test. If it is normally distributed, we will going to perform the parametric test. If it is not, then we are going to use the non-parametric test. Independent t-test is our parametric test. Corresponding to that one is man-Whiston test for the non-parametric test. So in simple word, we can say that how our data is drawn and distributed. If they are normally distributed, we are performing the parametric test. If not, then we are going with the non-parametric test. Commonly used parametric tests are, like, if our data is normally used, we can say that the most widely used tests are t-test, either unpaired, or you can say the independent sample t-test, or pair sample t-test, ANOVA, one-way ANOVA or two-way ANOVA, then linear regression, Pearson rank correlation. These are the commonly used parametric tests which we are doing in our, but there are some assumption, and one of the assumption is normally distribution. So if data is normally distributed, we are performing this type of test. If not, then for t-test we are going to use man-Whiston test. If for the ANOVA, if it is not normally distributed, we are and that man-Whiston test is non-parametric test. For ANOVA, if it is not normally distributed, we are going to do the Kurzweil-Wallis test. For linear regression, we are going to use what you call as a Spearman regression or Spearman for the Pearson rank correlation. Instead of that, we are going to use the Spearman correlation. So these are the things which we are performing when the how the data is distributed. Like, the general assumption of parametric tests are the population are normally distributed. Normally distributed in a sense, the range is in between, like there is a bell shape of for normally distribution. So outliers are very few. So this selective population is representative of the general population. So whatever the selective population is, it is the representative of the general population. Like it is not very extreme end population we are taking. No, those who are very commonly available and commonly represent the complete population, and the data is into the interval or normal interval or ratio scales. A non-parametric test can be applied when data don't follow any specific distribution and no assumption about the population are made. Means data can be selected from any other places and it is not normally distributed. Also, they don't belong to one particular area. So we are going to perform the non-parametric test. Some of the like this assume, for the parametric test we assume that the data is distributed normally, and any type of distribution, non-distribution is there. Assume variance, homogeneity is there, means similarity is there, but here doesn't require for the similarities. Type, typical type, not always, but typical type is ratio or interval type of data. Here ordinal nominal type of data. Data set relationship, they are independent to each other. And here any type of usual central measures, we all know about the mean, median, mode is a central measure. So the parametric test we are using the mean. For the non-parametric test, median or mode. Benefit can draw the more conclusive, and here less affected by outlier. Simplicity is there, but like correspond, I'm just going to see you the correspond, like correlation test. If my data is normally distributed, we are going to do the Pearson. It is called as parametric test. So correspond to this Pearson, there is a Spearman test, which is the non-parametric test. Independent measure, we all know about the independent t-test. What we are doing for the independent t-test, one categorical variable is there and one scale variable is there, and we are going to perform the t-test. Is there any significance difference between them, or is there relationship between them? If they are not distributed normally, in that case we are going to use the Mann-Whisky test. And in case of one way of one way ANOVA, one way ANOVA means if the one categorical variable is there having the 3, 2, 4, 5 category is there, we are going to use the one way ANOVA, and correspond to that one non-parametric test is crucial values. Repeated measure matched pair t-test correspond to that is non-parametric is Wilkinson test. One way repeated measure Friedman test. So for every type of data we may going to use the parametric test or non-parametric test, depend upon their completion of whether they are fulfilling the what you called as the assumption of normality distribution or normality of like that one or not. So I hope you understand why this parametric test or non-parametric test understanding is important for that one.